Hello, Crazy.
Hey man, how have you been?
Hello, New Year. Uh, I've moved to Sister, actually. A lot of fun.
Yeah,
Uh, yeah, I'm poking with the sharding, and it turned to be well, quite painful. Hello, Kifo. Hello, Mark.
Here, look. Hey guys.
Hi guys.
hey
So I just
folks.
realized I don't think it's on like the calendar. At least it didn't look like it was on my calendar, which is weird. But I don't know if we'll get everyone or not. Oh, we're getting enough people, so this is good. Good morning, Sage.
Good morning, everyone.
So I realized like 45 minutes ago that I had about 3 or 4 weeks worth of PRs to get through, and there was absolutely no way I was going to get it done by the time we started the meeting, so I didn't even bother trying. So next week I will have that updated, but for this week, nothing. Sage, is there anything you wanted to mention that you know about off the top of your head?
No, no.
All right. Yeah, the NUMA discussion would be good. All right, Sage, do you want to start us off with that since it's the first in the list?
Sure. Yeah, there was an internal thread about Numa pinning that I resurrected this morning. I should just move it over to the development list um, later today. But the basic idea is first add the infrastructure to Numa node. So add helpers for a given block device to determine what NUMA node it's attached to. And then for object store backend, look at any non-rotational devices that we're using and look at the NUMA node for all of them. And if they all match, then report that as the backend's NUMA node. If they don't match, then don't do anything, or if they're not rotational, or if they are rotational, then don't report anything. Report all that up through the OSD, and then just include that in the OSD metadata that's reported to the monitor. That'd be first part. Second part would be do the same thing for the NIC. So look at the IP, the public IP, and backend cluster IP that we're bound to, and look at the NUMA nodes for those. And if they match, then report that as the network NUMA node. Same thing, report that up to the monitor. Third
Why
thing
does
would
the
be to add.
why does the monitor need to know? Why isn't that just like a stat that's reported back through the manager?
Um, hold on, object store, block dev. Oh, sorry. Because the third thing,
Okay.
object store 3 for NIC, or the fourth thing is to add a Ceph OSD NUMA status or just NUMA command, something like that. That looks something like, let me paste this in. Something sort of like that. Where it'll just report the OSD, the NUMA nodes for the NIC and for the storage. And if we are pinning the OSD, how it's pinned. And if the NUMA nodes don't match, then we wouldn't pin. And then the fifth thing would be to, if match, automatically pin. If they don't match, do nothing, because who knows what the right thing to do is. We don't really know. And there'd be like a OSD NUMA auto pin or something through setting to control whether you do that. Basically, first part would just be to like have some visibility so that if it's clear that the storage is on one NUMA node and it's clear that the network is on one NUMA node, then report that so that admin can see it. And if the if it's unknown, say on this host, maybe we just don't know what the NIC is, or maybe the storage is ambiguous, then we could like do -1 or a dash or something, or just leave it blank or whatever. Right. But if we know that it's on one node, then whatever. And so then an admin can look at this and they can say, well, how come my storage isn't reporting a NUMA node? And if they go look and debug the system, then they'll notice that like their devices spanning to, they're using an SSD device and an SSD journal, an NVMe journal. So 2 NVMe devices, but they're on different NUMA nodes. Maybe that's why. Whatever, who knows? Or the same thing on the NIC. Maybe the NIC isn't reporting a NUMA node, and that's because their front end and back end networks are different. Or more importantly, if they are reported but they don't match, then they know that they're just either not using the right NIC, or they don't have a NIC that's attached to the same socket as their NVMe's. That would be a problem.
This is definitely one situation where I would think that for a lot of people that don't look at this kind of stuff regularly, some kind of like visualization of it would make a lot of sense, right?
Yeah. I think a simple chart like this is going to go a long way, because you can just look and see if they match or don't match.
Yeah.
Whether we want to go so far as to like raise health alerts if they don't match, I think is a little bit clear, because there are going to be a lot of deployed clusters that are totally fine that like are just, the hardware is just not not ideal, and there's nothing to be done about it. So raising a health alert doesn't really help. So I think that's why I think a NUMA status, just a command that you can run that just tells you what the NUMA status. Maybe we can service this on the dashboard at some point to like highlight in red the ones that are problematic, and in orange the ones that are like not ideal, and the ones in green that are fabulous.
Any 2-socket system with a single NIC is gonna flag stuff, right?
Exactly, right.
So
any 2-socket system where somebody did the front end and the back end network is also gonna flag stuff, because that's just, it turns out that's dumb. I guess 6 would be to rewrite this stupid out-of-date document, rewrite docs about front back networks for OSDs, because I think that's just a bad, maybe it made sense 5 years ago, but it's just bad advice now. People shouldn't use front end back end networks. They should instead put both NICs on the front end network, at least for flash clusters, both NICs on the same network, but separate IPs, and then balance the OSDs across them according to where the actual SSDs are.
Yeah. One thing that we haven't really done a good job of over the years, I think, is really focusing on like hardware topology, right? And part of this is because the vendors don't. Like, it's impossible or really hard to get the vendors to really like think critically about how the hardware inside the node is really laid out, or at least I always found it was myself. But as we move forward, we probably need to really do a better job of getting people thinking about this.
There is some command I noticed while I was Googling for this called ls topo, which is like a visualization of what the hardware looks like, where the PCI buses are, and all this stuff. I'm Googling it now, and I'm getting like pictures out of a GUI. I thought this was a command line application, but maybe it's actually an X application or something. But it tells you how the L1, L2s, L3 caches are, how the NUMA nodes are set up, and so on.
it kind of surprises me that there's not some kind of like cluster-wide view of this kind of stuff. Like you'd imagine that HPC sites would want some kind of nice,
Maybe there is. I don't know.
Yeah.
I'm not. Oh, this is the first time I've seen any of these tools. But yeah, if you look at like here, I'll put it in the chat. So like, this looks like a pretty good tool to see what the hell's going on on your machine. See if I can run it on mine. Oh. Fedora. Anyway, that's my update.
Cool. Well, probably not. Well, maybe this time, I don't know. But at some point, I still very much would like to talk about what an OSD really means and kind of what it means in terms of like a hardware architecture like this. When we're moving into a world where you have different NUMA nodes and lots of cores and lots of hardware in a box, what is an OSD, and why should it be one device, or should it not be one device, and should it be like a conglomerate of close by hardware, or what? I think I am falling into the mindset of thinking that an OSD should be a grouping of close by hardware, and that then it figures out how to divvy up that hardware that's within like a NUMA node. But it might very well be wrong. That's just kind of my current thinking, I guess. But maybe this kind of can lead us into the update that Radek you have, because you were just recently talking about that kind of other path of having an OSD be very simple and potentially like single threaded. So do you want to talk about what you guys are seeing?
Well, I just wanted to maybe not even talk, just ask for some input to the discussion we have around sharding in C-star. Basically, two approaches were identified. One is to make very simple OSD sitting explicitly on one OSD, on one core, consuming one core, having one thread, and everything asynchronous inside. Another approach would be to make the OSD more beefy, be able to span across multiple cores and do sharding internally. And both approaches are having their own advantages and disadvantages. In C-star, we had discussion, and the conclusion is that we don't know how to judge appropriately those pros and cons. And I would love to ask about the inflation of OSD map, especially. Let's suppose the biggest disadvantage of having simple OSD spanning only on one core is we would need to have a lot of OSD in cluster to saturate powerful devices, saturate NVMEs. This will translate this design translates into not saving some resources like network connections and also like OSD map entries. But well, is it a real problem?
I'm inclined to say it's not that big a problem, but I think also I wonder if it's inevitable, because if we're worried about, for example, having too many network connections, because we have, I don't know, because the thing is, it's not so much a core that we want to pin to, right? It's no, it is a core, I guess. So for C-star, we actually want like literally one core. Because at least for the network, we want to make sure that we would want the TCP connection to terminate at the core, because if we don't, then we're sharing the network stack across cores, and then suddenly we're sharing. And and we are sort of losing the whole point of all this. Like, I'm wondering if even if we had maximum flexibility, we could have an OSD for the entire host, for the entire NUMA node, for a single core. Like, if we could do whatever we wanted, I think we would still possibly want to squash those OSDs down really small, because the minute we're sharing network connections across cores, then suddenly we have all the cross-core synchronization.
Networking. I apologize for jumping here, but I mean, this seems to go back to the discussion that you and various people, Sam, Justin, and others had long ago about we had intuited that we really wanted to decouple OSD from network connection and have an ability to pipeline requests for a given OSD up on a network connection that's appropriate to it. But it shouldn't be necessary to have a whole new network stack invocation for co-located, for a group of OSDs that are co-located on a node.
Yeah, I mean, it certainly isn't necessary, right? And like at one end of the spectrum, it makes sense to have, one network connection between two hosts, right? Because there's no reason why you need parallel connections. The problem with that is that you suddenly have a point of contention and sharing, multiplexing all these flows across that single connection. And when the network traffic is arriving at that host, then you have to send it to the right socket and the right core for it to be processed. And it might actually be better to have parallel TCP connections.
Well, it might be better to have some number to avoid head line blocking, but it's not. But there's no dimensional relationship with OSD, or there really shouldn't be. The protocol should make it possible to efficiently.
There doesn't have to be, but maybe there's a performance reason, right?
Well,
because the minute you are sharing it across cores, then you have cross-core contention, and the network is being read.
That's all still good there at some layer in the stack, though. Just because we're not explicitly doing the memory movement doesn't mean that the kernel isn't having to do all the I/O through one core and then send it off to the right places.
Well, I'm just saying. Well, I agree with that, but that's a different point. I mean, I think all I'm saying is that I think the cardinality of OSD and network connection should be different, logically, for optimal efficiency as well. The only thing that comes in is HOL.
One quick question before going further, if I may. Are we entirely focused? Aren't we over-focused on kernel networking, on kernel things? I guess that the main, I guess that the main reason of getting Sister inside is just to bypass kernel. Sister is basically a scheduler, user space scheduler. It offers a DPDK-based network stack, and I bet that on powerful deployments, we will be going to use SPDK as well.
Yep.
It means bypassing kernel entirely.
And in that case, each instance of the OSD or instance of the network endpoint, however we carve it up, it's going to be a VIF, a virtual. I think that's right, VIF, the virtual network function, which means that the hardware is doing DMA into memory for us, and we're using DPDK, so there's no kernel involved. It should scale very well.
Well, yeah, but can it actually? I mean, I don't know the answer to this question. Can it actually go to like an actual DMA to every core in the system, or is it going to be stuck at 16 or something?
I think you can have one for every.
Yes.
For every socket.
Okay.
I mean, they're designed for virtual machines. You can have like 1,000 of them or something. I don't know. They're bazillion. The idea was to have the hardware pass through direct into a VM, so you get high performance networking inside a VM. That's, I think, what it was built for. But here we'd be making use of it for this. But I guess if that's the case,
well, okay, but I mean, VMs are used to running in shared hardware context, though.
In this case, my understanding is that this hardware capability was developed to support things like virtualization, where you had you wanted a high performance VM that was pinned to a CPU, had no scheduling overhead, and had direct access to the hardware. It was to support things like virtual network functions and whatever.
Cool. Anyway, I think Radic had somewhere else you wanted to go.
Yeah.
Well, I cannot say too much about SPDK or DPDK, but I had some experience with the third technology that is, I guess, made to be combined with both with the previous ones. I mean QAT. It's for offloading compression. It's for offloading encryption. And the sharing the single device between multiple cores, multiple programs, multiple applications were well designed from the very beginning, I guess. There is a concept of a hardware ring buffer, basically some kind of queue to communicate with, and you have a lot of those ring buffers, and they can be allocated at the setup phase of application by kernel and assigned to many processes.
I don't. One of the things that I'm a little worried about is that it feels like to me every time we hope or rely on the kernel or some other piece of software to do something well, it sometimes feels like we end up regretting the decision kind of in the future, right? That something doesn't work right and it's not easy to fix, and certainly not easy to fix by us. So anytime we can do something where we're more directly accessing the hardware or can fix problems ourselves, it seems like we take on a lot of work and it's really painful for us, but maybe it's the thing that in the very long term will.
QAT was needing the kernel assistance only at the setup phase. After setting up, when the hardware is ready, is set up, everything goes in user space.
Yeah.
In some cases, even with the virtual to physical address translation.
To clarify, how do you see the QAT example illuminating the discussion about whether the cardinality of OSD relative to the cardinality of core, the mapping of OSD to core?
Could you please repeat?
How does the QAT topic of QAT intersect with the
I'm just extrapolating my experience with QAT to DPDK and SPDK. I guess that those technologies have been made in very similar way.
I mean, it seems like
seems so. Yeah, talking to the online devices using PCI device interface, which is posted by the kernel. So it's a very direct way.
From a much more higher level point of view, one of the things that I've always been kind of interested in is kind of who makes decisions regarding data placement in Ceph, and we've been very reliant on Crush all the way down to the device level for a long time, and it's kind of good in some ways, but in other ways it's really the big problem it solves, right, is that it lets you avoid some kind of centralized lookup table somewhere. But maybe in a world where we're going to have really fast like NVDIMMs in every node someday in the future, maybe node level or even like NUMA node level, maybe you can do really fast lookups inside that node, and it gives you more flexibility about data placement locally. Like maybe the problem that Crush solves is much more relevant when you're spanning lots of nodes in a big cluster relative to like placing data within some very local NUMA node. Is that worth thinking about? Is that something people are interested in?
I mean, I agree, but I think that's a situation we have today where Crush maps things to placement groups. No, it doesn't do that. It maps placement groups to OSDs. But how those OSDs are mapped on the internal hardware is like we can do whatever we want there, right? Right
Exactly.
now we're just relying on the
Oh
crawl
yeah.
So I don't
I'm
know
talking
that
about,
changes anything.
well, I'm talking about
think-
where we're
I don't
spending
either.
resources, though, right? Like if we're really spending a lot of engineering resources towards a model where we have single-threaded OSDs that are really targeting like one device, or a portion of a device even. It's not that you can't do the other thing. It's just about where we've spent time focusing, I guess.
Well, I'm confused. Isn't the single-threaded OSD, isn't its function then to just be one reschedulable unit of work that is running on one core? And don't you still have potentially many requests, such requests in parallel? And so don't you really have an N by M mapping of N cores by M OSDs? Or
I think that
split by PG.
First, I want to just clarify when you say single-threaded OSD, you mean like a C star OSD running on one core with one C star thread, but a bajillion features and completions or whatever, right? That's what you're talking about?
I
So
think
that's the question. You're talking about a single core OSD?
Single core, I guess.
Yeah.
Yeah. Okay. Just wanted to make sure.
But that means absolutely no cross-core communication and no locking of any kind is even going to be necessary, right?
Right.
Because you're only going to one thread execution.
It vastly simplifies the design of the C star OSD. Assuming we don't try to like share the OSD cache, which or OSD map cache or whatever we could or couldn't do.
It does force you into a model though where you're sharing potentially on current hardware design. It forces you to kind of adopt a model where resources are shared across multiple OSDs, right? Where you're almost certainly going to take the hardware is shared. Multiple OSDs are occupying a given hardware resource.
Yeah, but I think the extent of that, I think there are two things that work in our favor. One, there's this newish BIF and NVMe namespace stuff, whatever that lets you. Actually, I'm not so certain about the SPDK side. We should double check if you can carve out multiple devices consuming the same SPDK device, physical NVMe. I'm not sure.
I don't think we rely on that from the discussions we've had. I don't think we want to rely on that from the discussions we've had. It's all like very small numbers of channel based, and if we lie, from what we've talked about, I don't think it's the right.
I mean, I think the thing to remember is that we're talking about intersecting reality like in a year, and so I think it seems like it's a question for what the roadmap direction is for the hardware manufacturers. Like, is this a thing that? What is the plan for? Is this a thing that is going to be normal, or is it going to be a weird special case? I think that's the. Well, we don't have a weird special case.
All the conversations we've had, and they're happy with it. They're not trying to push it forward.
What's that? Say it again.
I mean, the conversations I remember having, they're not trying to push forward those features at all, and it's not anywhere. And I don't think it's something we want. Like, I think the best case was that if we did this, then each OSD would basically have one of the flash channels, but once you do that, it's all super slow.
One of the what channels?
One of the internal channels in the SSD flash controller.
Yeah. So you have like parallel channels, right? So
what
Greg's talking about, right, is like,
But then you have no parallelization of the IO request for an OSD. It's just stuck if you get into a write or if you need to do an erase cycle. It's
Greg,
awful.
I agree with you. I'm really worried about this. Like,
well, I think we should talk to, our friends at Intel and Western Digital and find out how they're building stuff, because this is all changing quickly. I don't remember having these conversations. The last time I remember talking about this was like, more than a year ago, maybe.
Will there always be a range of form factors that we have to be able to adapt between?
Yeah, but I think for the ones that are like not the fast ones, all this matters less, right? So.
Well, it feels like there'll always I'm not sure. I mean, I feel like they're even for machines that are more complex and have more devices and more and more activation together, more cores. You want to be able to run in that configuration, even if you want to be able to slim down into some more isolated, dispersed units. If that someone starts building that,
Yeah.
Sage, the other thing I wanted to get back to too is that I feel like that model really locks you into Crush as the distribution mechanism, right? All the way down to like a partial device level. Like you're relying on very much a static, pseudo-random distribution. But you might not always want that, right? Like especially in the future, it might be where you want some kind of like ability to say this device is in the middle of some local maintenance or local, it's busy. I have NVDIMMs. I can, make really quick choices about where to put something.
Right.
Maybe you want to do that internally.
Or maybe we want to have some sort of local redundancy within the node, right? We've shied away from that traditionally, but like, I don't know that we have a good reason to do it necessarily.
And maybe we don't right now, but maybe we want the option. Maybe we don't want to close. We're not really closing it off, right? We're never really closing it off, but maybe we want to retain some. We don't want to make it really hard for ourselves to do that in the future.
Yep. Yeah, I guess what I'm getting at is I wonder if this actually is going to work in more situations than we think. Like it might actually work pretty well. It's not like that. I mean, ultimately, if we have an OSD that lets us sort of use as many cores or as few cores as we want, and either like put everything into one mega OSD daemon for the whole host, or have one per core per device or per slice of a device. Like
partition even.
Maximum flexibility sounds great. We can handle everything, but there's a huge cost to that in terms of the code complexity and the time it's going to take to actually develop something. And I guess what I'm wondering out loud is that wonder if what we should focus on as sort of phase one is implementing a simple case that's not going to be completely general, but actually is going to probably cover 70% of these high performance cases, and degrade somewhat gracefully, and then get that working. That'll sort of give us like sort of the upper bound, because it's the easiest case. Like it's all in one core. There's no whatever. And then start adding in all the complexity to, maybe we just want to be able to multiplex on the network side, but not on the storage side, or maybe the other way around. Maybe we want to multiplex storage or whatever, however we want to do it.
The complexity side is a very interesting point to talk about. Well, I saw some discussions from a couple months ago related to the approach to take for Crimson OSD, and they were mostly focused on performance side. But there is even more important one, I guess: correctness and complexity.
Mm-hmm.
If you have one C-star thread in OSD, it's still more complex, but quite acceptable. If you have even a bit beefier OSD, I mean multiple C-star threads, but not sharing any resources, perfectly sharded without changing shard in the middle of the request processing, still can live with that. But in situation where you have multiple C-star threads exchanging data between them, well, it's the pain start there.
Mm-hmm. Yep.
Well,
sharing data in C-star should be made using message passing, but there is absolutely no language toolset to prevent you from accidental sharing. Well, even sharing is not the sole thing you need to take care about. Even the allocation of memory on proper core is another pain. Sure, C-star has foreign pointer, but it's like a unique pointer of C++. It's not for sharing.
Yeah. Yep.
That's the reason why. Yep.
I guess I would be curious to hear Kifu's thoughts and what the other people on the C-Star Crimson team.
Yeah, were there some
regarding
specific
foreign pointer, it also has two versions of shared pointer. It has lightweight shared pointer, which is for a reference count on a single core, but it also has the non-lightweight shared pointer. So there is actually a way to use shared data across cores that's supported by the system in the cases that we need to. Generally, read-only data. If you actually want to do modification from multiple places, you almost certainly want to just send a message to the core that owns its mutability to do the updates. At least all own a reference to it and read it.
So Radic and Kifu, were there because I think you've been working forward on the assumption that you'd have multiple cores per OSD in a C-Star process. So were there specific problems you've already run into that prompted this question, or are you just wow, it would be really cool if we just didn't have to do any of the work? Because it would be really cool if we didn't have to do any of the work. It would be so much simpler. I'm just really, really scared of tying ourselves into that at a whole lot of levels.
How did the decision arise to have multiple C-Star cores in a single OSD? I mean, I thought the original idea was sort of mapping PG to a core, and then you have a potentially
but that's
multiple cardinality of OSDs on
messenger, I guess.
Yeah. So is it just the messenger and passing the messages to the right core for the PG, or was it when they started writing the OSD map cache sharing code, or?
I guess, well, from the discussion I can find on Ceph level, it appears about to be connected somehow to the crossbar we would need to have, but I'm not sure it's entirely correct. In the case of very simple OSD, having one thread only, well, we would not have to implement the crossbar in OSD, because the crossbar basically will be fulfilled with the current crash infrastructure.
Wait, when did this come up on the Ceph mailing list?
This doesn't I don't follow that either. I mean, the crossbar means,
came up
when you say crossbar, do you mean cross-core message?
Yeah.
Because I think crossbar is
it's
problematic.
It's a logical crossbar because you have some core that's handling the network traffic coming in, and then it has to pass it off to whatever core is handling that PG. So there's some inherent crossbar between the messaging layer and
that has always made sense. But I think I think you're on the right path. When you're talking about having a particular OSD try to be, or at least even specific, maybe even by invariantly be a kind of a logical task on that is so a single thread. But then you have the possibility of having an appropriate number of those allocated on any particular core. With affinity, and you have the fixed affinity in Crush of PG, but pricing systems that aren't like Crush. I mean, I strongly think the idea, the notion that the high level benefit of Crush, and systems like it, of being able to infer what physical, the sort of high level physical topology of a thing, or the steering information about an object is incredibly valuable and resurfaces in future topologies also, even if there are fabrics or subfabrics that would have allowed us to get for more than one location to access a particular piece of data. I still see a role for what Crush gives you there.
Yeah, I don't think there's too much question there. The reason why I'm thinking about this is just a comment that Radic made, I think it was yesterday in the Blue Source stand-up, about what if we just made an OSD one core? Would that be feasible? And I guess my main motivation for talking about it now is just, I think we should be either at least calling out and questioning our assumptions, because we sort of went into this whole C-star discussion assuming that, or I did at least, assuming that an OSD was going to be multiple C-star threads.
Well, I assume the opposite, but I think it's really interesting. But I mean, is there any question that I mean, apologies for keep bringing this back up, but I mean, for my my mental process is that seems like the building block or a building block. But is there any
which does
the idea that you have not the same thing you just said, but a permutation of what you just said, Sage, that an OSD has a logical core or a logical mapping to a core or a thread of control in C star. But it didn't seem necessary to me to assume that there's only one per core.
Oh no. Maybe I didn't even think about that. But basically I was going from previously I was thinking about an OSD being N cores to being just one.
Yeah, I think it's intriguing.
Rid of all of this complexity with
I think that leads to a much more composable architecture as well,
but it does it has a huge benefit in terms of the code complexity. The cost is that we rely on the virtualization function in the network and on the storage side. And so I think in order to prove out whether this is actually a viable path, we need to.
Do we have to? How does that virtualization function into play? I mean, there's some natural
one physical network interface on a host, and you're going to have 32 OSDs or something if you have one per core, and so they each need to have their own independent IP stack and set of TCP connections.
Well, hold on. Isn't it possible that there's another that there is instead one such stack or one such that complex is one-to-one with core complex and not OSD, even in the single OSD thread concept?
Well, then you have the crossbar.
You do. Right? Well, you're often going to have those crossbars, or cross-core.
No, that's the point, Matt. If we have that crossbar, then we're paying the complexity of doing the memory core tracking. Right?
Well,
if we're going to bother,
I speculate. I see what you're getting at. Well, okay, I'll be quiet. I sort of suspect.
There's one.
I sort of suspect that the idea of factoring that out completely from the design and not making it a fundamental primitive that can be accomplished is sort of fruitless. You'd have to almost build dedicated hardware just to accomplish it. I don't. We're going to get there.
Well, yeah. So if you're not, that means that we're relying on a performance map or being able to equally align the performance between between one CPU core and a chunk of storage. And
I think that's
we've
the
not
question.
been successful with that in the past.
It's the storage side that concerns me. On the network side, I'm not concerned because you have this that already exists, and you can rejigger your networks, and it's all dynamic. So who cares, right? The network side is easy. It's the storage side, and I think the question is, at the end of the day, once we are sort of done with this whole process, how much is it going to be one modern CPU core, one modern NVMe? Or is it going to be 4 cores per NVMe? Or is it going to be a quarter of a core to one NVMe? What's the balance going to be? Because currently we spend 8 cores keeping one NVMe busy, but we're paying all this complexity. It's the code is horribly inefficient. If we actually could do it efficiently, what would the endpoint be? Because I can't really tell because I can see it going both ways. I can see us wanting to have push 1 million IOPS into an SSD, and you're gonna want to be able to spend different amounts of CPU, and maybe you're doing erasure coding, maybe you're not, whatever. On the other hand, I also see that the vendors want to build these boxes that have 64 12 terabyte NVMe sticks in one box. How many cores are they going to put in there, right?
Sage, I think
it's kind of going to be about 1 per NVMe.
No, Sage, the answer is easy. Cores aren't getting faster. They're not, right? Cores are not. CPUs are getting faster. You're getting more cores, but they are not getting faster. But an NVMe drive, as a conglomeration of lots of channels with lots of parallelism, is
right.
So unless you can do what Greg was talking about and start assigning cores to specific channels of NVMe one.
I think that's the question that we need to talk to WD and Intel about and find out what is the hardware roadmap, what do they expect is going to happen here? Because I think there is something that's analogous to VIF for these NVMe drives. I don't know if it's the namespace or if it's You know, if you have 64 channels, each one gets 16 dedicated channels, or whether they're getting multiplexed in the controller. Who cares? Or maybe, well, I guess we do care. We care, but I don't know what the answer is. But I think that's the question, and that's going to determine whether this one core per OSD has legs or not.
Sage, there's one other thing I wanted to ask you about. Back when I was working on Pet Store, I had proposed kind of this very simplified OSD model, and you were really against it then. Is it just the ability to do this kind of virtual, was it VIF, whatever they call it, kind of direct access to the hardware that kind of has swayed you in the other direction, or is there something else that?
I'll be honest, I don't remember what your proposal was.
It was very, very abstract in the get rid of all of the everything, just make a single core OSD that does event, basically an event model. But then that was kind of with the assumption that maybe you're just going on a typical file system or something. You don't carve it up the device directly using all these new user space technologies. So that's why I'm wondering is kind of what's kind of pushed you in what's your
Well, I think it was Radek's comment on Monday just made me question this. I went into this whole thing assuming that we needed to have something that was very general and that we would have a crossfire. I just assumed that a crossfire was going to be a requirement. And that we were going to need to be able to carve up the OSD, the devices, the network in various ways. We might have multiple OSDs in one process sharing the same network, or maybe we would, I don't know, I sort of assumed that we'd be building something with maximum flexibility. But I think I sort of arrived at those assumptions or assumed those assumptions, whatever, forgetting about the fact that the network lets you sort of avoid that, because you can have, at least to the best of my understanding, you can have independent DPTK stacks working against a VIF using the hardware virtualization function.
Yep.
I didn't know you could do that. I didn't used to know you can do that. So I think that's part of the reason why I sort of assumed that a requirement was inherently fundamentally required.
That's kind of the key piece then, is that you can
I think
now
that's the key piece. And I'm kind of assuming, I'm kind of assuming that there's going to be a similar capability on the NVMe side. And I think that's in my mind, that's the big question.
Well, okay, you need to email some people then, because we've asked that, and the answer was no, not really. Like, there's an interface that looks like it might do that, and the internal implementation, it's a lie.
Yeah.
At least that's what I remember from when we asked about the channels in the past. The other thing though is it's good to question your assumptions, but I mean we have, or at least I've been in conversations that did touch on this sort of stuff in the past, and I'm really, really nervous about specifically requiring the performance of all of the pieces to align. I think we're going to be in use cases where that's just not true, and this is going to be our only code path. And so I would like to see very explicitly what we've done so far that makes us think that losing this programming complexity is worth that loss of generality. Because it is simpler, but if we don't build it in, it makes the primitives a little more complicated, but I don't, from what I've seen, and I mean, I'm an outside observer, from what I've seen, it doesn't look like it's that much more complicated, and it's going to be really hard to retrofit onto an existing code base.
It might be also that we don't need that generality, that the huge performance will be, the expectation to get huge performance will be not general. It will be focused on particular devices. I mean, nobody cares about performance of spinners.
Well, except it's not actually true. We're mostly good enough, so we mostly don't care. But if we get into more deep archival use cases, and like with these big object RDW clusters, we actually do care some. Now, not because we can't saturate a hard drive really, really easily, but because we're trying to shove more and more hard drives behind a single CPU socket. And it's also not just about the CPU amount of CPU used, but that the more, if we do one OSD as one core, that means we have, 16 or 32 or 64 time OSDs per box guaranteed. We can't reduce that number at all. It means that we have that many copies of all the live OSD maps in the system, and they're larger. And that's more memory that might be used in a low memory ratio environment.
Yep, I totally agree.
I'm really nervous.
Your point, Greg, is well taken, because regardless of what the top line hero number, whatever is, and what the right balance is for that with the fastest hardware in every category, the reality is that a hardware that our users are going to use is going to be like wildly varying, right? So I think the question is, like, if you think of, in my mind, I'm wondering if we think about sort of the most extreme case of being these machines that are just like packed with NVMEs and packed with cores, if there's a model that lets us carve off a bunch of complexity that can handle that case, and that piece that gets carved off isn't the lower performance stuff, then that's a win, right? For example, in the single, where OSDs live on a single core, that's totally fine with spinners, right? You could have like 16 OSDs on a single core, and that doesn't change your software complexity at all. And so that model gracefully degrades to all the slow stuff. The question is it sufficiently general and flexible to handle the high-end stuff?
Well, right, so it degrades the slow stuff in CPU terms, but I'm not sure that it does in memory terms. Oh, go ahead.
Should we be so focused on saving memory? I see huge increasement in complexity just to squeeze some network connection, the number of network connections, the number of entries inside of OSD map, and I'm not sure it's just worth.
So I would love it if you can enumerate. If you can enumerate the huge increase in complexity you're seeing, and like write it down, like send an email to Ceph Development. That's what I want to see. Because you're closer to this than I am, and I'm sure there is complexity. Like I know there is. I've talked about some of the data design. No, I really want to see it written down, right? Because we need to think real hard about it.
I agree.
Because yes, like we use a lot of memory right now, and and the increases we've had in using memory are causing trouble not just for like homebrew lab users, but for some of our commercial users. So yes, like the amount of memory we use for our static overhead is something we need to be careful of.
Is there new information or really discrete information that I may have missed about where most of the memory utilization is? My understanding in the past was that a lot of it went into PG. Are OSD maps actually currently dominating?
They don't currently dominate. They've caused trouble on like our Big Bang clusters at CERN, though.
They're the biggest shared thing that shouldn't have to be shared. But I think they're sufficiently out of band that introducing complexity, just for example, as a hypothetical, for a shared OSD map cache across OSDs and cores, so that we eliminate the network crossbar, but we only have this cross-core communication for a shared OSD map. Like that would be.
Back in the day when memory was really expensive, AFS got wins by using UDP because it kind of it avoided head of line blocking and it garbage collected all the overhead of early TCP stacks. I don't know how long I don't know if we're ever going to get back there. HOL is going to be significant, but I just think of hardwiring the decision like we're going to have one network stack per OSD seems odd given the way Crush works.
If we make the assumption that we're going to do one OSD per core in the future, if we get away from one OSD per device, but just say one OSD per core, what in 5 years or 10 years, how many OSDs does that mean for a cluster? And how big are those?
Well, again, I certainly wouldn't have thought there was only one OSD per core. I would have thought that OSDs would have one core, which is what Sage said originally.
Yeah.
Sorry. Yeah, you're right. Yeah. So even worse, right? But even potentially.
No, not worse. Better.
No,
Not worse.
better.
Okay. Oh.
Yeah.
Oh. Multiple. Okay. But Radix
Well,
proposal
yeah.
is not
No,
that, right?
Radixslav's automaton is aimed at that model.
Yeah, an OSD would not span course. That's the simplifying
Yes.
thing.
Exactly.
So I guess you're worried, Mark, about 5 years from now when you have a 256 core system, and suddenly you have 256 OSDs on one box. Like, what is that?
How big do your maps get? How much memory now are you really using per OSD for OSD map?
Yeah, I mean more, but I wonder if that's maybe that's I don't know. Maybe that's necessary. Maybe not. Yeah, you're right. Oh, yeah, I don't know.
And the growth isn't linear, right? The growth is exponential. Because the maps get bigger and you have more of them on every box. So it doesn't keep up with potentially the memory growth as the core growth increases.
Well, it wasn't. I don't know if Emerson is on the phone call, but back when we talked about this, we conceived this problem before. We didn't conceive it quite in the same hardware specific way, but we assumed that this could be solved by sharding or fragmenting and isolating relevant portions of maps to subdomains.
Okay, sure.
It's something I thought about. But the thing that I'm unclear about is, in terms of pure complexity, the crossbar seems like less of an issue than stuff like PG split merge or even a shared OSD cache. Since at worst, the crossbar is just we allocate memory on one thing at the beginning of a request, and then all the way at the end, when we finish the request, we have to send a message to deallocate it. Deallocating memory by sending a message isn't the bad part. It's all the other stuff that I'd worry more about.
It's the stuff. Yeah, no, you're totally right. Split and merge are a huge headache that are more of a concern. But I think it's not so much about the allocation deallocation, at least with my limited understanding. It's that you have the messenger reads it off the network and probably does a CRC check and then hands it off to another core. And so it's no longer in the L1 cache because that other core, when it then does any additional processing or sends it off the network.
Yep, you are getting all issues related to multi-threaded programming, plus the extra complexity, the extra headaches coming from C-star.
Yeah.
And some resources in C-star just cannot be moved, like connected. They need to stay on the core. They need to stay on the core where they have been created on.
So I think Greg got the right question, because this is really about simplifying the design to avoid a bunch of programming complexity. And we have most of us not actually working on the code, trying to make this complicated value decision or whatever when we actually haven't looked at any of the code. And so I guess what I would ask is that Kifu, if you can bring this up in the next Crimson call, and maybe report back on what you guys collectively think of this idea. Like, how much is the savings in terms of code complexity? Does it tie our hands in other cases? Whatever. Also, those folks probably know something about the hardware virtualization capabilities, or whatever the right term is for the SSDs. I can reach out to Tushar separately and see what Intel's take on that is. But it feels like that's sort of the next step in order to move the conversation forward.
Yeah, probably I can send a mail to you guys to try to invite you guys to the next Crimson Core, and send a mail to summarize some of the problem or assumption we have regarding to the complexity introduced by the crossbar messenger, and some of the question and assumption regarding to how to shard the underlying storage, how do we make use of it using the multiple threaded, single threaded OSD design.
Yep.
I would also like to talk to Alfredo about what does it mean in terms of the complexity of having to divvy up hardware for different OSDs or whatever you want to call them, right? And with static allocation saying this is a portion of an LVM device that gets given to this small OSD and this other one and this other one, versus kind of the model of you hand some resources associated with a NUMA node to this OSD conglomerate thing, right? And it figures it out. Because for me, that's kind of one of the things that's driving my viewpoint on it. Is it seems like trying to make high-level decisions about what OSDs need, it doesn't work as well as the OSD itself making decisions about what it can use and where it should use it.
I think the good news is that all of this is focused on like pure NVMe devices, and 95% of the complexity and the Ceph volume stuff that Alfredo has been working on is all the other crap where you have like you're carving it up into 12 pieces and sharing it among a bunch of hard drives and whatever. I think a lot of that is less of an issue. So
you don't think we'll hit that with like NVDIMMs and Optane devices for other NVMe drives? I mean, it seems like we're going to hit it again.
I think the Optane stuff, well, I'm hoping that either you're just going to have Optane devices or non-Optane devices, and you're not going to like have like an NVMe and a piece of an Optane. And that in the case where we're doing persistent memory, it's going to be actual DIMM form factor, and so it'll be a little bit easier to manage. I'm hoping, but I don't know. Who knows? There are a lot of questions. But
for our lab, Intel's giving us a bunch of slower NVMe drives plus like one or a couple of Optanes, I think, per node. So it is exactly that model, right?
Yeah, but we might not necessarily want to do a hybrid OSD, right? Like for hard disks, hybrid OSDs really made sense because the flash was so much faster than the OSD, and it was so much easier to get good performance out of the hard disk with a little bit of flash. I'm not sure that the same holds true with quote unquote slow NVMEs versus Optane. But maybe, I don't know.
I maybe we're running out of time, but I want to challenge that assumption in the future because I don't think it's true.
Yeah.
But
yeah, you might be right. I don't know. Anyway.
Just to add more to the sharded versus not sharded discussion, there is also another very good reason to actually do sharding. Advantage of the more beefy design that Kifu already pointed out. It's the C-Stars IO scheduler.
That it gives it to you for free, or?
Sorry?
So what's the advantage?
The possibility to employ the C-Stars IO scheduler, user space IO scheduler. You can do a lot more with scheduling IO, prioritizing particular kinds of IO operations. That's good, very good finding, very good reason, very good advantage for the beefy design.
Would that mean like we can prioritize? Sorry, when you say prioritize like that, what's like the interface for that? Like how would you envision using it?
Well, I guess Kifu could say a lot more about that.
It basically allows us to share a device by assign different tasks with a share. For example, if a task should have a more share, we can assign it a number like 17. If another task should have a less share, smaller share, we can assign a number like 2. It's just how nice a device should be.
Okay.
To different tasks.
I see.
It actually allows us to share a device for different C-Star consumer. So even if we do not have a hardware support, like assign different user with a different flash channels, we can use it as an alternative.
Yeah. Okay. All right. Well, that's probably enough.
Yeah.
Okay. Thanks everyone for a lively discussion, and looking forward to hearing what the rest of the Crimson team thinks about the idea.
Adam, sorry we didn't get to the RocksDB sharding topic.
Next time.
Maybe next week. Yeah.
Does it work?
Not yet.
By the way, the Crimson meeting will be held in very late in NA time. It's like 11 or 10 p.m.
Okay. On Wednesday, next Wednesday. Okay.
Yes.
All right. Have a good one, everyone. Thanks.
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 Peter.
There, guys.